Math 110. I want to spend a few minutes talking about some of your homework problems from section 3.3. These are circuit problems, and maybe you're not having any trouble building the circuits or reading the circuit and writing it down, but what I want to focus on is the simplifying part and to show you some techniques to simplify circuits. On the test, I have decided to make simplifying circuits a bonus because I can't remove that part of the circuit question. So if I ask you to write a circuit or what is the logical form of the circuit, I can't get rid of the second part that asks you to simplify. But I am going to make that a bonus, and that's not because I don't think it's important, but the book does not truly prepare you for what it takes to simplify it, but I still want to show you some techniques to get it done so you can complete the homework, and also if you choose to do that part of the bonus on the test. So here's one of your homework questions. You might not have this exact question. Remember, it's just iterations of this problem, but you might have this exact question. Write a logical statement representing the circuit to the right. Simplify the circuit if possible. So what I want you to realize when you're looking at a circuit is whenever you have a circuit in a straight line, that's going to be an and where it splits up, this is going to be or. So not looking at the choices, I know that this would be Q and, because that's in a straight line, and then this is going to be P or Q. Now we've got to be careful, because if I leave it like this, Q and P or Q, I would have to work this problem left to right, which really means the Q and P go together, or Q. Okay, so that's not what we really want. We really want the P or Q to go together, and the Q is in line with that. You see what I mean? So make sure you realize if you have a parallel circuit, which is the box here, that's an or statement, and you have to put that part in parentheses. If you'll notice your choices, the one without the parentheses is an available choice. But now if I were to draw that circuit, Q and P or Q, now don't laugh at my circuit, but Q and P would be in line. So here's Q, and here's P, okay? And then or Q would be a box down here with Q at the bottom. So that, all right, so for the second question, we were supposed to write a logical statement representing the circuit to the right, simplify the circuit if possible again. So I want you to be able to write a logical statement for the circuit. Those are very straightforward. Whenever you have a parallel circuit like we do in this box here, that's going to be an or. And then when you have a circuit or a switch in line, that's going to be an and. So we call the R and the Q here, those are switches, and the not P is a switch. And again, the parallel is or, in line is and. You do need to use parentheses. So we have, the pen's not working, stand by. We have R or Q. Again, because that's parallel, I need that in parentheses. And then in line is and, not P. Okay? So do we see that option, R or Q and not P? I do. Mine happens to be first right here. I do always want to check my other options to see if there seems to be something very close and maybe I've overlooked something. There's R and Q or not P. Notice they have the and the or mixed up. So I feel confident about that answer. I submit that, and then what happens is simplify the circuit pops up. And then you go back and you look at your formulas. Okay, there's a big list of formulas. You know, I've got a couple highlighted that we tried to use earlier to simplify. We ended up not really using them because they didn't help us get to a simplified answer that was in our multiple choice list, but we try again. Now, if I go back and look, here we are. Is that where I am? No, not at all. I apologize. That's where we are. Okay, so we're trying to simplify R or Q and not P. Now, if I use the formulas, I could write this as, let me show you, R or Q and not P. I could use one of those distribution type properties before. I could write that as R or not P. Okay, so I'm putting this R and not P, and then the or in between, and then Q and not P. But now here's the unfortunate thing. That even looks more complicated. It's bigger, right, than the original, okay? Now I have found when circuits have 3 different letters going on, R, Q, and not P, they often can't be simplified. So the most logical thing here is to put this can't be simplified. Now I do know that R or Q and not P is not equivalent to P and Q and or R. Okay, matter of fact, we can't get rid of that negation in front of the P, so that one and that one are totally out. But even if I leave the negation in front of the P, okay, I can't just drop the parentheses, and that's somewhat what this line is saying, so that's out. And then here, it's all ors, so that's out. And again, I know it's hard to, when the answer is it can't be simplified, that's a challenge to see, especially when you're first learning how to do that. But when you have 3 different letters going on like this and you've got parentheses, there's really not going to be a way to simplify it. You can use that formula, but actually it got bigger rather than more simplified. Okay, I know that's not a touchy-feely good answer either, but there you go. All right, next question. Draw a circuit representing the following statement. Simplify if possible once again. Okay, now this time they give us not R and Q or R. Now I'm not looking at my choices here. I just want to try to draw this out based on what it says. So it's an and, look, not R and. So I need to draw a switch with a not R in line. That gives me an and, okay? Now this is an or statement. That's going to give me that parallel circuit. In other words, the box. Okay, what goes in there? Q, R. Now, does it matter if the Q's on top and the R's on the bottom, or if you put R on top and Q on the bottom? It does not matter. When you're dealing with a parallel circuit, the order of that doesn't matter. So now I go in and I look at my choices. So I need a not R in the front, which means this guy's out and this guy's out. Okay, I do have a not R in the front here, and it says R. Okay, so the last video just stopped mid-sentence on me. I'm going to try to finish this up as quickly as possible. We decided that this was our correct answer. All right, now let's see if we can simplify that. So I have not R and R or Q. If I use my formula sheet, that would be not R and R or not R and Q. Correct? Okay. All right. Now, I noticed I wrote my original in a slightly different order than what they said. I was actually looking at the circuit over here when I wrote it down, but that doesn't change this. So, not R and R. Y'all, that is always false. You can't have not R and R. Okay? So, that's false. Or not R and Q. What does that mean? So not R and R, you can't have those both true, right? An and is true if they're both true. So in any other situation, it's false. Because if R is true, then not R is false. And vice versa. So that's false for sure. Now we have an or. Now if you have a false and an or, then it depends on what this is. Okay, so what I'm trying to say is because you have a false here, it depends on what this is. If this were true, if you had a true on the left, then this would be true. It wouldn't matter what was over here. But since you have a false, it's going to depend on the truth value of not R or Q, which means this is our simplified result, not R and Q. I said or Q, I apologize. Not R and Q. Okay? So again, if you feel uncomfortable with that, you could do a truth table with your original statement and compare it to each one of these below. And then if none of these work, then you could use that one. That's not my favorite method. I like to use the formulas, but even the formulas are not strong enough. There's not enough there to get you through all of these issues. You kind of have to think your way through it. Exactly why that's a bonus. Let me squeeze in this last problem. This is not a simplify, but I do want to talk about it. So we have P or Q. Remember, that is a parallel circuit. If I were to draw this circuit, I would have to do a box, and that's what we mean by a parallel circuit. So P or Q, so I have P or Q. And then an and, so now I'm in line. But then it splits up to another or, so I have another box. Again, not pretty, I'm sorry. And then it's not R or S. So my answer should look like this. Now we kind of have to be careful because I have found that it's really hard to see the knots here. Like this is P and Q on the top and then a big or, but that looks like a knot right there. Not R or S, but that doesn't like ours anyway. This one's out because it's just a big box. This one's out because it's, again, a big parallel circuits with an and on the inside. Ours is an and, so it splits up. It's one of these two. And you got to be careful looking for the negation, though. This looks like P, Q, as it should be. This looks like a not R, and you can't hardly see it. And maybe you can see it better than I can, but that's a negation above that little dot above that R. That's it. Okay, this one's not because it has a not P here, Q, and then RS. Okay, I do hope this helps. I'm sorry the video split up into two pieces. There's actually something wrong with my video creation tool right now, and I'm just doing the best I can. But I do hope this helps, and I hope you have a wonderful day. Reach out with any questions you may have.